Hey everyone, Mr. Schachter here to help you turn fractions into decimals, okay? The first way to convert a fraction into a decimal is just to memorize it. There's a lot of really famous fractions that decimal equivalents are just simply known. And here's a couple of famous ones. 1/4 is 0.25, 1/2 is 0.5, 1/3, for example, is 0.3 repeating, so on and so forth. So if you look in the document that I have shared with you, right below it where it says watch the video, there's a list, there's a link you can click, and it'll bring up all the fractions that you'd have to learn, and you can just simply commit them to memory. Okay? So if you're able to do that, at least with some of the harder ones, like 1/8, then you'll be in really good shape. Number two, if you don't have it committed to memory, or it's kind of one of the easier ones, try to get a denominator of 10 or 100. Our number system is base 10, so multiples of 10 make the fraction very easy to turn into a decimal. Let's do some examples. If I take 2/5 and I want to turn that into a denominator of 10, I can just simply double the top and double the bottom. Doubling the top yields 4, doubling the bottom yields 10. This fraction is known as 4/10. 4/10. And that, as a decimal, is just simply 0.4, because that is the tenths place, and there are 4 of them, 4/10. Another example would be 31/50. Obviously, you can't turn that into a denominator of 10, because 31 is prime. But you could turn that into a denominator of 100 by doubling the top and the bottom. If you double 31, you get to 62. In double 50, you get to 100. So this fraction is known as 62 hundredths. Hundredths. And so as a decimal, that would just be 0.62, because this is the hundredths place. And so there are 62 hundredths in that. So that would be the decimal. Last resort, you can always turn a fraction into a decimal by using long division. Just make sure the numerator goes in the box. This is extremely excessive if it's an easy one. You should not be doing long division if it's easy. But 1/8, for example, might be one that you don't really know, and you certainly can't get a denominator of 10 or 100. So you'll have to use long division if you don't memorize this one. So I'll show you how to do that. Just remember that the numerator goes in the box, so the 1 goes in the box, the 8 goes outside of the box. You ask yourself, how many times can 8 divide into 1? Well, 8 can't fit into 1, so we say 0. Now, obviously, the answer is not 0. We have to keep going. So we add the decimal point after the 1, and then we add a placeholder. And this now is not 1.0, but we think about it as 10. And we ask, how many times would 8 fit into 10? Well, 1 time, of course. 8 times 1 is 8. And then we minus 10 from 8, or 8 from 10 rather. 10 minus 8 is equal to 2. 8 does not fit into 2, so we have to add yet another placeholder to make it 20. Okay? And then we say 8 fits into 22 times, because 2 8s make 16. Subtracting 20 and 16, you get 4. 8 goes into 4. Unfortunately, it does not, so we have to have yet another placeholder. 8 fits into 40 exactly 5 times. 8 times 5 is exactly 40. Remainder of 0. Can't really fit it. There we go, 0. So the decimal is right here. This is the quotient, 0.125. So this can be a way you can get the answer from a fraction to a decimal. All right, it's a last resort, though. Only use it for trickier ones. Let's talk decimals to percents. So if you have the decimal, finding the percent is actually very easy. All you have to do is move the decimal point twice to the right. If you move the decimal point over and there's no number there, you put a 0 as a placeholder. Here's an example. 0.43, decimal point is right here. Once, twice to the right, becomes 43%. Next one is 0.2. Decimal point is right here. Once, twice to the right. But notice there's no number after the 2. That's when you put the placeholder 0. So 0.2 is 20%. 0.375, decimal point, once, twice to the right, 37.5%. Don't forget about that 5. Don't ignore it. It's still in the problem. This one's a little trickier, 0.3. Well, remember that 0.3 actually represents an infinite number of 3's, right? This is really what that bar means. So if the decimal point is right here and I go once, twice to the right, I end up with 33 and then 0.33333 repeating indefinitely again. But you have to remember that 0.3333 repeating is 1/3. So this would be 33 and 1/3%, because all these extra 3's that we have, that represents 1/3. Keep in mind that to go in reverse, of course, you just move the decimal point twice to the left. So if you have, for example, 43, the decimal point is right here. All you have to do is move the decimal point over twice to the left, which would be 0.43 to get the decimal. So going from decimal to percent, you go to the right. Going from percent to decimal, you go decimal point to the left 2 spaces. Okay?